Nonlinear systems in two variables. A nonlinear system has at least one equation that isn't a line or that isn't linear. We're going to use the substitution method that we have used to solve linear systems to solve nonlinear systems. And in this example, we have x squared plus y squared equals 4. So this is a circle of radius 2, centered at the origin, and a line here, 3x minus y equals 4. So in this particular case, we have 2 points of intersection, but it would be possible to have no points of intersection. We could end up with 2 nonlinear equations and 4 points of intersection. So if a nonlinear system in two variables does have a solution, the number of points of intersection will vary depending on the equations. In this example, the first equation is a circle, the second equation is a line. I'm going to solve b for y, so y equals 3x. I'm going to substitute that into a, so that means x squared plus 3x all squared equals 10. It's going to end up with 10x squared equals 10, and when I solve that, x equals plus or minus 1, and I'm going to substitute, so when x equals negative 1 from part b, y equals negative 3, and when x equals positive 1 from part b, y equals positive 3. So there are 2 points of intersection, negative 1, negative 3, and 1, 3. Negative 1, negative 3, and point 1, 3. So in this example, I'm not given a choice. I have to solve the system using the addition method. So I'm going to multiply a by negative 3, and I'm now going to get minus 3y squared plus 25y, so that's 22y squared, and then 26 minus 78 plus 100, so that's 22, so that's the new b or the equivalent b. And when I solve y, I get y squared equals 1. So y is either plus or minus 1. I'm going to substitute back in a. So when y is plus or minus 1, actually, I get x squared plus, and it's the same if it's plus 1 or minus 1, squared equals 26. That actually tells me x squared plus 1 equals 26. So x squared equals 25. X equals plus or minus 5. And I'm going to have 4 points of intersection. I'm going to have negative 5, negative 1, negative 5, 1, and 5, negative 1, and 5, 1. Negative 5, negative 1, negative 5, 1, positive 5, negative 1, and positive 5, positive 1.